So this is now a question. We're doing counting principles with repeated letters or digits. So the question says a code is made up of first two letters, which means first two position must be occupied by two letters, and three digits. So third, fourth, fifth position is three digits. How many possible codes can be formed given that we must remember that our letters are repeated. So now the next part, given that the first letter must be A, first digit must be a number less than 2. Then last part, what is the probability of choosing a valid code? So the first part says how many possible codes can be formed. So let's see possible codes. This is equal to, we have first position, second position, third, fourth, fifth. So in this case, we have, how many letters do we have to arrange at the first position? We have 26 letters. This one is before restrictions. So we have 26 letters to arrange. Multiplied by, we also have to multiply by 26 letters on the second position. Third position, now we're starting digits. How many digits do we have from 0 to 9? These 26 letters is from A to Z. Then now on digits, it's from 0 to 9. 0 to 9, we have 10 digits. So we arrange 10, 10, 10. What is the answer? Then if we multiply, we get 676,000. Those are possible codes that we can form. Then now, the restrictions are applied for us to get a valid code. Do we have five positions? So we're told that the first letter must be A. So first letter is A, which means how many letters are we arranging on the first position? It's just one letter, which is A. So we say 1 multiplied by second position. We are arranging, here we don't have any restriction on the second position, so we have 26 letters to arrange. Next position, how many digits can we arrange? You're told that the first digit must be a number less than 2. So we only have 2 digits to arrange, which is 0 and 1. So we have 2 multiplied by third position. The second is fourth position, doesn't have restriction. So we are arranging 10 digits. Here we're also arranging 10 digits. Then we get on our calculator, I'm getting 5,200. 5,200 is my answer. So now I want to see the third part, which is the probability of selecting a valid code. Probability of a valid code. This is equal to possible outcomes. It's equal to valid codes over possible codes. So our possible code, valid code is equal to 5,200 over number of possible codes, which is 676,000. If we want to express this as a percentage, we can multiply by 100 here. Then we get 0.77%. That's the probability of choosing or selecting a valid code. Now we're doing counting principle with repeated letters or digits. So in this case, we don't want to see any repetition of letters or digits. So the question reads, a code is made up of first 2 letters and 3 digits. Given that letters or digits may not be repeated, calculate the possible codes that can be formed. So we have 1, 2, 3, 4, 5. So first two position are letters and they are not repeated. So whereas we must know that first position we are arranging 26 letters, which is from A to Z, but we are not repeating any of the letters. So which means the second position we are left with 25 letters to arrange there. Then first position, which is for digits, we are arranging 10 digits. Then second position we are left with 9 digits to arrange. Here we are left with 8 digits to arrange. Then we get the answer. Our answer is 468,000. So those are the possible codes that can be formed. Then now they said for a code to be valid, first letter must be A, first digit must be a number less than 2. So now I want to see how many possible valid codes that can be formed. So the first position, I said it must be a letter. The letter must be A. So we only have one A in our alphabetical order. So I am arranging 1. Then we are left with how many terms to arrange? We're left with 25. Then they say the first digit must be a number less than 2. So we have 0 and 1. So here we are arranging 2 letters. After arranging those 2 letters, it's either we're arranging 1 or 0. We can't arrange them at once, 0 and 1. So we're arranging one of the 2. So the second position, we're left with 9 digits to arrange there. Multiplied by, now 9 is gone. So we're left with, we arranged 1 digit here, 1 digit there. So we're left with 8 digits to arrange, which is there. Then we multiply, then we get, our answer is 3,600. So let's see the probability of selecting a valid code. Is equal to 3,600, which is valid code over possible codes, over 468,000 multiplied by 100. Then this one, if we divide it, we get 0.77%.